Mysterious, strange, and mind-boggling are all understatements in the quantum realm. Richard Feynman once said, "I think I can safely say that nobody understands quantum mechanics." What exactly is quantum mechanics? The word quantum originates from a Latin word for amount. It can also mean the smallest possible unit. Mechanics is a branch of physics concerning the forces applied on systems. Therefore, quantum mechanics is simply the study of incredibly tiny systems and the forces that govern them.
When we go down to the subatomic scale, the laws of classical physics break down. In quantum mechanics, one can never simultaneously determine the position as well as the momentum of a particle. This means that the indecisive electron can split into multiple probabilities and move in two directions at once. The electron situation is said to be in superposition of those states. Here is an example, the double-slit experiment.
In this experiment, a light source illuminates the entire plate, pierced by two parallel slits, and light passing through both slits is absorbed on a screen behind the plate. The nature of the light waves, when passing through the two slits, cause interference behind the plate, producing light and dark bands on the screen. On the other hand, imagine you have a gun, and you repeatedly fire it at the two slits. You have two bands where bullets can hit, but no interference pattern. However, if you take a more exact light source, like an electron gun, and you fire the electrons one by one, let's see what happens. Since electrons are particles, we should get two bands. Remarkably, an interference pattern emerges when these particles build up, indicating they are also acting like a wave.
This interference pattern can be considered the wave function, the collective probabilities on how a quantum system can act. Furthermore, this superposition introduces an indeterminacy known as wave-particle duality. It states that electrons and photons can act like waves and particles in different situations. Nonetheless, when an experiment observes electrons, the superposition is reduced, also known as the collapse of the wave function. The collapse occurs when a wave function appears to condense, by the observation, to a single certain state. In the physics community, there are two popular interpretations to this: the orthodox position and the realist position.
In the orthodox position, the electron is a particle and a wave, and wave-particle duality is a law of nature.
This experiment may take a stand as one or the other.
In the realist position, the electron's indeterminacy isn't a law of nature, but a reflection of our ignorance. Think of classical mechanics as Earth's crust, and quantum mechanics as the underlying mantle.
There are things about the mantle, however, that only make sense if you know the workings of the inner core.
Whatever the answer is, quantum mechanics shows the world is not what is seen just by the naked eye, but something which is far beyond our comprehension. But we will always continue to ponder the universe's many mysteries. For now, the quantum realm remains one weird place.